Hello, let's look at ways you can express our domain model. Let's look at domain objects. We have different types of domain objects and we'll also look at how to classify them. We'll start with entities. These are objects defined by their identity and not their attributes. They represent a thread of continuity that runs across time and distinct representation. Let's look at an example of this. We have 3 students on the board. We have 2 with student ID 12 and 1 with student ID 14. When you look at the ones on the top left and top right, these are seemingly 2 different students, but they are the same person because they do share the same identity. Again, you don't always have to go with ID as your identifier, as your identity, as your unique ID, but it's mostly what is used. But again, you can also use something like name. In our system, we ended up working with ID. So in this case, it is a differentiator. That means the 2 students at the top are the same person. There may be a case where the student changed their name at some point and their class was also changed. So that's why they seem to be 2 different people, but they are the same person. When we look at the student on the bottom, that is student ID 14, we see they have the same name as the top left student. They're both called Mokiri and they have the same class, which is J. So they do seem if you look at them from without the ID, they do seem like the same person, but they are 2 different people because they have different identifiers, they have different identities. One more thing to note is that mistaken identity can lead to corruption. We've seen how that can happen in our example here, where we had 2 different students but with the same details, but they were 2 different people by virtue of them having different IDs. So that's one thing to really be clear about. Get an identity, get an identifier that really separates people or objects or whatever you're dealing with in your system clearly, so that you don't have a case of corruption. That's it on entities. Let's look at value objects. Unlike entities, they have no conceptual identity. We'll see an example of that. They describe some characteristic of a thing. It will be more of a description of something else most of the time. So let's look at this example here. We have 3 different timestamps. A timestamp has nanos and seconds. So we'll look at these 3. We have the top left and the top right very different by virtue of the nanos being different. One thing to note, unlike the entity, they do not have identifiers. They don't have any identity. They're just 2 different things. In this case, the top left and the top right are different by virtue of their attributes being different. We see here that the nanos are different, so that makes it a totally different value object. But if you look at the value object at the bottom, it is very similar to the one on the top left. That means it is the same value object. When you're looking at value objects, they're only the same value objects that you're dealing with when all the attributes are the same. The moment you change anything, then that becomes a different value object. Tracking the identity is not essential and can hurt performance. Now imagine a scenario where you're assigning IDs to timestamps every time you use them. It will be very hurtful to the system. It's very unnecessary. Like imagine tracking that. You don't really need to know the life cycle of these. I'm tracking all the different dates I'm using on my system. That is going to be very disastrous for you. So just don't do that. When it comes to things that mostly describe that don't need that identity, that don't have continuity, just use them as value objects and don't assign an identity to them. How do you classify them? How do you know the difference between entities and value objects? For one, does it represent something with identity? If it does, then you know it's an entity, and if it does not, then it is a value object. Another thing is you have to check if it represents something with continuity. Again, if it has continuity, classify it as an entity, and if it does not, it is a value object. And last but not least, you have to check if it describes the state of something else. Ideally, value objects are usually there to describe other value objects, so they are actually attributes of an entity or part of another value object. So if that's the case, then it's most likely a value object. Let's look at domain operations. I classified these on their own because they do not fit into domain objects. An example of that is service. This is a service that is done for a client on request. I'm sorry for using the same word to describe it, but we'll get to have a better description as we go. So this is an activity that represents something the software must do, but that does not correspond with state. One thing to really note here, this does not have any, it should be stateless. We'll look at more details on how to do this better, but this is mostly used when you have some details that you need to sometimes cross between two different states. So in this case, it should be stateless. I don't own any data of my own. My work comes only when it needs to execute. Think of it as instructions you're giving it, but specifically on the domain model level and not on the outer layers. And also, as I said, this should be stateless. You need to be really keen on this, and that's how you design a service. We look at more details on how to do services and when to use them when we're talking about services on their own. And that's it on ways to express a domain. Thank you.